Hi everyone. Today we are going to talk about real-life application of first-order differential equation. Well, when we are learning math, the end result is that we're going to use math in real life to solve problems. So let's get started. We will start with the classic tank model. So when you are in algebra, you probably remember that it was similar problem about there was a tank and then there was a pipe pumping in water into the tank, while another pipe pumping out water from the tank. Today we are going to use a similar setting because it's classic. Even though I never understand why in real life people are going to pump water into a tank and pump water out of a tank at the same time, or are they thinking wasting water? But it's math model and it's classic. So let's don't judge it. Let's just start solving problem. So let me read the question first. Our 200-gallon tank is half full with distilled water. At time t equals 0, a solution containing 0.5 pounds of concentrate per gallon enters the tank at rate of 5 gallons per minute, and the well-stirred mixture is withdrawn at rate of 3 gallons per minute. At what time will the tank be full? So at t equals 0, we know that the tank was filled halfway with water. So we have 100 gallons in the tank. And then we know that from the question, there was 5 gallons per minute entering the tank and 3 gallons per minute leaving the tank. So this is just simple algebra. 5 gallons enter the tank, 3 gallons leaving the tank. How much is the water in the tank increasing? 2 gallons per minute. So isn't that easy to see? There are 100 gallons of water starting initially in the tank, and then the water was increasing at 2 gallons per minute. Our equation would just be 100 plus 2t equal 200 because one is a tank full. We need 200 gallons to fill the tank. And solving it, we get t equal 15 minutes. 15 minutes. So 15 minutes for question part A. For question part B, we have said that at the time the tank is full, how many pounds of concentrate will it contain? Well, we know that so we are trying to find how many pounds of concentrate was in the tank at time t15, and we know that the water was entering the tank at 5 gallons per minute, and this water contains 0.5 pounds per gallon of whatever solute it is. Therefore, we just need to times them together, and then gallon will cancel gallon, and we get 2.5 pounds per minute. So after we know that 2.5 pounds of whatever that is will enter in the tank per minute, we need to define a variable. So AT, I will state that it stands for the amount of concentrates in the tank in water at time t. The unit for t was minute, and the unit for A will be pounds. So great job. Let's start solving this problem. So a classic equation for this kind of problem will say that A prime, which is the change in amount of concentration, was equal to the amount of concentration coming in minus the amount of concentration coming out. And we get it from a minute ago that the amount of concentration entered in was 2.5 pounds per minute. So now we just need to minus the concentration going out. So how should we do that? Well, the amount of concentration coming out matter with the amount of concentrate in the solution. And AT stands for the amount of concentrates in this water. And then 100 plus 2t give us the volume of the water at time t. Therefore, AT unit was pound, 100 plus 2t was gallon, so this gives us pounds per gallon. Now let's just times 3, the amount of solution going out, which is gallon per minute, and the gallon cancel out, we get the amount of concentrate going out in pounds per minute. Then we need to find AT. So we know how to plug in T, which is 50 minutes, so we know what A is. So how should we do it? Well, A prime equal 2.5 minus AT. You know what? Let's just put A, so it will be let's arrange it. Just looking at it, we can tell it look really similar to the linear first order differential equation. And what do the linear first order differential equation look like? So let's just replace y with a and x with t. So 3 over 100 plus 2t, isn't that somewhat kind of a function t? And 2.5 can just be a function t, right? So yes, a match. And how do we solve it? Well, we need an integrate factor. That's literally how should we solve it? And we know p of x here was 3 over 100 plus 2t. And if we type it into the calculator, that will give us, I need more space. And we know anything times ln of something can become ln of something of power, so like basic algebra, and E cancel, so it's our integrating factor, and we tie the integrating factor to every part of the equation, and then we see that the front will just be so. Let's just look at the second part of the equation, and we know derivative of this is t, sorry, will give us a 3 square root of x plus 15 divided by 2, and then, well, t. And then 100 plus 2t was equal to 2 times 15 plus t. And then when 3 over 2 divided by 15 plus t, so it's like some kind of a number 3 over 2 divided by it will give us square root of 8, right? So this will give us square root of 15 plus t. So at this reasoning, we can tell the equation on top was just a times derivative of 15 plus t 3 over 2. Sorry, my screen have some problem, the word do not show. But anyway, remember the first part of the other equation is a prime of 15 plus t 3 over 2. Isn't that remind you of something? Yes, the product rule. Let's just treat f of x as a and g of x as 15 plus t 3 over 2. Isn't that match the product rule? So this is the proof of why when you time the integrating factor, the left will become derivative of a times 15 plus t 3 over 2. And I mean, if you get the right integrating factor for linear function, your front will always be y times the integrating factor. And the other side we get from the last part, which is 2.5 times t 15 302. And if you integrate both sides, you get, and later on it's just algebra. So what will be the constant? We know at times z t equals 0, there was only distilled water in the tank, so concentration value should also be 0. Therefore, 0 plug it in will become 15 5 plus 2 plus c, so c equal negative 15 5 over 2, and then divide both sides by t plus 15 3 over 2. 2 over 2, which will be 1. So it's just t plus 15, and then 2 t plus 15, negative 3 over 2 for its divide. And now at t15, what would this be? 3 over 2. Calculator said it's about 2.32 pounds. So that's our answer for B. Now, question C are asked to redo A and B, but this time the amount of solution entered tank was 1 pound of concentrate per gallon. Well, since the amount entering in was still 5 and amount leaving out was still 3, so part A will actually don't change. It's still t equal 15 minutes. But part B will definitely change. So this time the amount entering was 5 times 1, giving us 5 pound per minute entering in. So S in minus S out. So the amount entering was 5, and then the amount leaving amount of solute in the water over the volume of the water, which is concentration, and times 3. The unit cancel out. So this is our new equation. Now we follow the same step to solving it. So a prime plus a over 100 plus 2t 3 equals 5. Again, linear. And we take the, what do this give us? Again, what do we have for last time? Well, do I need to repeat this stuff? Same integrating factor. So times both sides, and the only difference was like here it becomes 5 times. Take the derivative. We all know this is just math, which is algebra. And when t go to 15, A was approximately 4.64 pound. Thank you very much. This is the end of today's video.